The National Electrical Code, or NEC, does not contain specific prohibition against using electrical boxes with knockouts on walls or machinery. The primary concern with electrical box installations, regardless of location, revolves around ensuring proper support, secure connections, and protection of conductors. Knockouts are designed to provide entry points for wiring, and as long as the unused knockouts are properly closed with appropriate knockout seals or closures, they do not inherently violate any NEC regulation. The integrity of the enclosure must be maintained to prevent the ingress of dust, moisture, or other contaminants, especially in environments where such factors could compromise the safety or performance of the electrical system. When installing electrical boxes on walls, the NEC emphasizes the need for secure mounting. Boxes must be adequately supported to withstand the weight of the attached devices, conductors, and any associated equipment. The specific requirements for support vary depending on the size and type of box, as well as the wall construction. For example, boxes mounted on wood framing may be secured directly to studs or with the use of mounting brackets. In contrast, boxes installed on concrete or masonry walls may require anchors or other specialized mounting hardware. Additionally, the NEC addresses the proper methods for connecting conduit or cables to electrical boxes. Fittings must be appropriately sized and listed for the specific type of raceway or cable being used. Furthermore, connections must be made in a manner that ensures a secure and reliable electrical connection, as well as provides adequate strain relief to prevent damage to conductors. When it comes to machinery, the NEC also focuses on ensuring safe and reliable electrical installations. Electrical boxes mounted on machinery must be able to withstand the vibrations, movements, and environmental conditions associated with the equipment. This may involve using specialized mounting hardware, vibration-dampening materials, or flexible conduit to minimize stress on connections. Furthermore, the NEC addresses the need for proper grounding of electrical equipment, including machinery. Grounding helps to minimize the risk of electric shock and provides a path for fault current to flow back to the source, allowing overcurrent protective devices to operate and clear the fault. The NEC specifies various methods for grounding electrical equipment, including the use of grounding conductors, bonding jumpers, and equipment grounding conductors. In addition to these general requirements, the NEC also includes specific provisions for electrical installations in hazardous locations, such as areas where flammable gases, vapors, or dust may be present. In these locations, electrical equipment must be specifically designed and approved for use in the particular hazardous environment. This may involve using explosion-proof enclosures, intrinsically safe circuits, or other specialized equipment to minimize the risk of ignition. While the NEC does not explicitly prohibit the use of electrical boxes with knockouts on walls or machinery, it is essential to comply with all applicable requirements for support, connections, grounding, and environmental protection. Failure to do so can increase the risk of electrical shock, fire, or equipment damage. To elaborate further, several sections of the NEC could be relevant when assessing the permissibility of using electrical boxes with knockouts in various applications. Firstly, NEC Section 110.3. E mandates that listed or labeled equipment shall be installed and used in accordance with any instructions included in the listing or labeling. This means that if an electrical box is listed with specific instructions regarding the closure of unused knockouts or limitations on its mounting locations, those instructions must be followed. Secondly, NEC Section 314 addresses the installation and use of outlet, device, pull, and junction boxes, conduit bodies, fittings, and handhole enclosures. This section provides detailed requirements for box fill calculations, support, and mounting. For example, NEC Section 314.17 specifies the methods for supporting boxes, and 314.16 outlines the rules for determining the number of conductors permitted in a box. Thirdly, NEC Section 400 addresses flexible cords and cables. Although this section may not directly pertain to the installation of electrical boxes, it is relevant when considering the wiring methods used to connect equipment to the boxes. Flexible cords and cables must be protected from physical damage and strain, and they must be properly terminated at both ends. Fourthly, NEC Section 430 covers motors, motor circuits, and controllers. This section includes requirements for the installation of electrical boxes and enclosures used to house motor control equipment. The NEC emphasizes the need for adequate ventilation and protection from environmental factors such as moisture and dust. Fifthly, NEC Section 500 through 516 address hazardous locations, as mentioned earlier. These sections provide detailed requirements for electrical installations in areas where flammable gases, vapors, or dust may be present. Electrical boxes used in these locations must be specifically designed and approved for use in a particular hazardous environment. To summarize, while there is no specific NEC rule that outright prohibits the use of electrical boxes with knockouts on walls or machinery, it is crucial to adhere to all applicable NEC requirements for support, connections, grounding, and environmental protection. Unused knockouts must be properly closed, and the installation must comply with any instructions included in the listing or labeling of the equipment. Furthermore, the electrical boxes must be suitable for the specific environment in which they are installed, taking into account factors such as vibration, moisture, and the presence of hazardous materials. Remember to always consult the latest edition of the NEC and any applicable local codes or regulations to ensure compliance. It is also recommended to consult with a qualified electrical inspector or engineer to address any specific questions or concerns regarding electrical installations. Always prioritize safety and follow best practices when working with electrical systems. Firstly, ensure all power is disconnected before working on any electrical components. Secondly, use appropriate personal protective equipment, such as safety glasses and insulated gloves. Thirdly, inspect all equipment for damage before use. Fourthly, follow the manufacturer's instructions for installation and operation. Fifthly, test all circuits after completing the work to verify proper operation. Sixthly, never work alone. Seventhly, be aware of potential hazards and take steps to mitigate them. Eighthly, if unsure about any aspect of the work, consult with a qualified electrician or other expert. Ninthly, maintain a clean and organized work area. Tenthly, properly dispose of any waste materials.